Hello everyone. This is our second lecture for Chapter 2. In this lecture, we will focus on measures of central tendency, the mean, median, and mode. So far, we've discussed that the purpose of descriptive statistics is to make data understandable. We've looked at some ways of getting that understanding graphically. It's always a good idea to get a feel or visual for the shape, spread, and center of our data by looking at graphs. Next, we will learn how to describe data values or scores numerically. We will see several statistics and parameters that can be used to represent the center of the distribution. These statistics or parameters are called measures of central tendency. These are numerical values that refer to the center of the distribution, or what we call the typical value in the distribution or data set. Before starting this chapter, please be aware that we will be working with formulas. These formulas are not designed to confuse you. Hopefully, you will come to see that they actually provide a very efficient way of describing data. Tips for success. Think of each formula as a statistical recipe. The ingredients of each formula are written using statistical symbols. Before you use each formula, be sure that you know what statistical term each symbol stands for. For example, the symbol N, as you will learn in this chapter, means number of data values, observations, or individuals. Then, step by step, carefully follow the formula to come up with the end result. As with any recipe, it may take a few tries to master this process. Practice will help you master the formulas. Also, don't forget to focus on understanding the logic behind each formula. Measures of center numerically describe the average or typical data value of a variable. We hear the word average in the news all the time. The average miles per gallon of gas for the 2018 Chevy Camaro is 22 miles for city driving and 31 miles for highway. Or according to the U.S. Census Bureau, the national average commute time to work in 2015 was 26.4 minutes. Or, according to the Bureau of Labor Statistics, the median household income in 2016 was $59,000. When the word average is used in the media, it usually refers to the mean. But beware, some reporters use the term average to refer to the median or the mode. These measures of central tendency can give very different results. Before we discuss measures of central tendency, we need to consider whether or not we are calculating a measure of central tendency that describes a population or one that describes a sample. For example, if we calculate the average quiz score for all students in a statistics class, or population, the average is a parameter. If we calculate the average based on a simple random sample of 5 students, the average is a statistic. When used in everyday language, the word average often stands for the arithmetic mean. To calculate the mean of a set of data, the data must be quantitative. The mean of a variable is the sum of all the scores of a variable divided by the number of scores for that variable. The rule for figuring the mean is to add up all the data values or observations and divide by how many there are, or the number of observations. The population mu is calculated using all the individuals in a population. The population mean mu is a parameter. Remember, in statistics, Greek letters are used to represent parameters. The formula for the population mean is mu equal sigma x divided by nu. Sigma, the capital Greek letter sigma, is the symbol for sum of or summation. It means add up all the numbers for whatever follows. X stands for the scores of the variable x. This tells you to add up all the scores or observations for variable x. Nu, capital Greek letter nu, represents the size of the population. The sample mean m is calculated using sample data. The sample mean is a statistic. Remember, in statistics, English alphabet letters are used to represent a statistic. The formula for sample mean is m equal to sigma x divided by n lowercase n. And n here represents the size of the sample. Most of you are probably familiar with both of these formulas, or at least are familiar with calculating the mean. So let's take a look at the basic properties of the mean. There are two that we're going to talk about. So the first one, the mean is considered the balance point of the data. And two, for a skewed distribution, the mean is pulled in the direction of the longer tail. The mean can be highly influenced by an outlier, which is an unusually small or unusually large data value or score. An outlier is a data value or score that falls well above or well below the overall set of data. These are the characteristics of the mean, based on the fact that every score in the distribution contributes to the value of the mean. Changing a score, changing any score, will change the sum of the scores, or sigma x, and so will always change the mean. Adding a new score or removing a score will change both sigma x and n, the number of observations, and you will need to compute or calculate a new mean. Adding or subtracting a constant from each score will change the mean by that same constant. If a constant is added or subtracted to every score, then the same constant is added or subtracted to the mean. Multiplying or dividing each score by a constant will change the mean by that same constant. If a constant is multiplied or divided, then the mean is multiplied or divided by the same constant. The mean is only one way to describe the typical value in a data set. A different measure is the median. If you line up all the data values from lowest to highest, the middle score is the median, the midpoint of the data values when they are ordered from the smallest to the largest. The median is the point that splits the data set in two, half the data below it and half above it. Kind of like the median on a highway splits a road into two equal parts. When the number of observations is odd, the median is the middle data value. When the number of observations is even, the median is between two numbers. In this case, the median is the average of those two numbers. Steps to finding the median are pretty simple. You put the values, number one, or step one, put the values or the data in order from smallest to largest. Number two, determine the number of observations, n. Number three, if the number of observations is odd, then the median is the data value that's exactly in the middle of the data set. Step number 4, if the number of observations is even, then the median is the average of the two middle observations in the data set. Here is an example for locating the median with an odd number of observations. As you can see, these data are already in order from smallest to largest. So in order to locate the middle score, or divide this exactly in half, we take a look at the number here, and we see here we go. So what you'll notice is that 8 is right smack dab in the middle. It divides this data set exactly in half, where 2 data values are below 8 and 2 data values are above 8. Does everyone see that? So our middle score is 8. So the median is equal to 8. All right, so now here's an example for locating the median with an even number of observations. So again, this data set is already in order from smallest to largest. And when we look at this data set, we notice that in order to divide this in half, we're going to have to take the average of the two middle scores, because the median is actually somewhere between 4 and 5. So in order to calculate the median here, we're going to have to take the average of 4 and 5. The average then is 4 plus 5 divided by 2, which is 4.5. As we learned earlier, the mean is highly influenced by extreme scores or outliers. The mean is not resistant to extreme scores. The median, on the other hand, is resistant to extreme scores. It's not affected by outliers. In a perfectly symmetric distribution where there are no outliers, the mean equals the median. In a skewed distribution, the mean is further out in the long tail than the median. If skewed to the right, the mean is larger than the median. If skewed to the left, the mean is smaller than the median. So let me show you this. So what you'll notice is here, in a symmetric distribution, the mean is equal to the median. In a positive skew, the mean is larger It's to the right of the median, which means it's larger than the median. In a negative skew, the mean is smaller than the median. It's to the left of the median, which makes it smaller than the median. The third measure of central tendency is the mode. Mode can be calculated on either quantitative or qualitative data. The mode is the only appropriate measure of central tendency for qualitative data. That's something for you to remember, that if you're dealing with qualitative data, the mode will be the only measure of center or measure of central tendency that you can use. The mode of a variable is the most frequent observation of the variable that occurs in the data set. To calculate the mode, count the number of observations that occur for each observation. The data value that occurs most often is the mode. A set of data can have no mode, one mode, or more than one mode. If no observation occurs more than once, we say the data have no mode. If a data set has two modes, we say the data are bimodal. If the data set has three or more modes or data values that occur with the highest frequency, the data set is multimodal. Which measure of central tendency should be used when? The mean is used when data are quantitative and frequency distribution is roughly symmetric. The median is the middle score or data value that divides the bottom 50% of the data from the top 50%. It is used when the data are quantitative and the frequency distribution is skewed left or skewed right. It's used when the distribution has missing or unknown values, or the variable is an ordinal scale. The mode, the most frequent observation, we use when the most frequent observation is the desired measure of central tendency, or the data are qualitative, nominal, or discrete variables.